Hello everyone, welcome to an algebra tutorial video. We're going to be learning about how to factor the special case of when we have a difference of two squares. So here we go. And just as a forewarning, these are some of my favorite things to factor because once you get the hang of it, once you can identify that there's something special going on, they're actually the easiest thing to factor. So here we go. We've got a binomial, 25w squared minus 16. And these are the only binomials we can actually factor. And even though it already is a binomial, it is possible to break this down into two binomials multiplied together. So you have to think back for a little bit about when we multiplied polynomials together, we had some special cases as well. And what we saw was when we had a polynomial, such as in this case, if I had something with a plus b, and I multiplied that by another binomial with the same terms a and b, but they were subtracted, we saw that there was something special going on, right? If I multiplied them together, we ended up with just a squared minus b squared. Because the middle terms end up canceling each other out, I would have ab minus ab. And so we don't even worry about the middle terms. So we're just left with a binomial result, a squared minus b squared. Well, now for factoring, we're trying to go in reverse, right? So I want to be able to recognize, well, when do I have this case, a difference of two squares? And then I can rewrite it as factored form. And that's what I have going on in this case. So here we go. 25w squared minus 16, is that a case of something squared minus something squared? Well, yes it is. 5 squared is 25, and 4 squared is 16. So I have the difference of two squares, w squared as well. So I can rewrite this as 5w plus 4 times 5w minus 4. Now let's check this out, just in case you don't believe me here. Let's multiply it together and see if it works out. So 5w times 5w, 5 times 5 is 25, w times w is w squared, minus 4 times 5w, which is minus 20w, plus 4 times 5w, so there's plus 20w. Oh, there's my middle terms that are going to cancel out, and 4 times negative 4 is going to be minus 16. What happens when I simplify things out? I'm left with 25w minus 16. So it checks out. So this binomial factors into this right here. This would be my answer. If I want to factor, if I have to factor that, my answer then is it factors into 5w plus 4 times 5w minus 4. Okay, let's do another example. I've got 81x squared minus 1. So it's a binomial. It is being subtracted. Are these two things squared? Well, I know 9 squared is 81, so that's good. This 1 is a little bit tricky, but until you think about it, that 1 squared actually just equals 1. So this is an example of a difference of two squares. And I can rewrite it as 9x minus 1 times 9x plus 1. And that binomial is the same as those two binomials multiplied together. We've got a factored form of it now. Let's go ahead and multiply it out just to check things out, make sure. I'm going to rewrite it here. And let's do the multiplication. 9 times 9x is 81x squared. 9x times 1 is plus 9x. Negative 1 times 9x is going to be minus 9x. And negative 1 times 1 is minus 1. Look at that. My two middle terms canceled out. Plus 9 minus 9. And we're left with 81x squared minus 9, or minus 1. So there we go. There is my answer in terms of rewriting that binomial in factored form. Hopefully that's helpful for you. Again, these are my favorite special case of when we have a difference of two squares. Now notice this only works if it's subtraction. For example, if I have a squared plus b squared, it doesn't fit the pattern. It looks like I could factor it, but I can't. It has to be the difference. So a subtraction sign has to be there of two things being squared.